Hello, everyone. It's great to see you online. I'm Song Guanfu from SuperMap. Today, my topic is exploration of distributed GIS and Geoblockchain technologies. The history of GIS development has proved to be a history of fighting against the ever-expanding geospatial data. We keep on developing new technologies in order to cope with the ever-growing data. The geospatial data grows rapidly. Classic surveying and GIS data is massive data. As the new generation of surveying technology develops, more new data joins, making the data even larger. For example, BIM data, point cloud data, oblique photogrammetry data, and so on. Geospatial big data is even bigger, which is generated from cell phone locations, IoT, social networks, etc. The traditional GIS software is facing big challenges. The performance declines rapidly with the increase of data volume. For example, an overlay analysis would take more than 10 hours when polygons of data reach 100 million. Traditional GIS cannot manage streaming geospatial big data. For instance, cell phone location data, which is more than billions records per day per city. Then what shall we do for it? The so-called distributed GIS refers to by using multi-machine distributed collaboration technology to execute a large number of tasks by clustering, or to split a single complicated task into several subtasks, which can be executed by several machines at the same time. The development of distributed GIS has evolved a long way. In 2004, SuperMap launched WebGIS service cluster technology. It is a part of the distributed GIS. In 2011, we launched Cloud GIS Smart Cluster technology. And in the recent years, we have launched Cloud Native GIS technology. This is the first branch line. The second line is Edge GIS technology, which is developed through GIS distribution server. The third line refers to that when we implement geospatial big data analysis function based on distributed computing framework, we found that this technology could improve the performance of massive classic geospatial data analysis and processing. The fourth line is using distributed database technology to manage geospatial data. Geoblockchain belongs to the distributed geospatial data management technology. So we can build the architecture of distributed GIS technology. It consists of 5 major technologies. They are distributed spatial data engine technology, Geoblockchain technology, distributed spatial analysis and processing technology, cloud native GIS technology, and Edge GIS technology. Now, I would like to share some progresses of these. The first one is Edge GIS technology. It is said that an octopus could think with its legs because there are 40% of its nerves are in the brain, while 60% in its legs. The legs could not only feel, but also could think. The edge computing is similar with octopus legs. In the framework of classic cloud computing, it takes long time of network latency while terminal accessing to the cloud directly. So we deploy the edge servers on the edge side near the terminals to process the requests from terminals. It could reduce the network latency and improve the performance of the whole system. SuperMap iEdge is an edge GIS server software developed by SuperMap. It provides 3 capabilities, including edge server aggregation, edge geospatial data delivery, and edge geospatial analysis and processing. Cloud GIS, edge GIS, and terminal GIS constitute the product system, which has the feature of cloud, edge, terminal, distributed collaboration. We provide 3 software packages for Cloud Center and provide edge GIS server for edge side near the terminals. Also, we provide terminal GIS for desktop, components, web, and mobile. Comparing with Cloud GIS, the edge GIS has low network latency and bandwidth consumption, which means high performance. The second is Cloud Native GIS. What we call Cloud Native GIS is natively designed for cloud architecture, which gives full play to the flexibility and the distributed advantage of cloud. There are 5 elements in Cloud Native GIS. They are microservice, containerization, automatic arrangement, continuous delivery, and DevOps. The former 3 belong to technology, and the left 2 belong to process. What are microservice and containerization? The traditional WebGIS architecture is a single framework. The crash of a certain module could cause the crash of the whole system. So we divide GIS server software into several modules, and they can run independently in different containers. These containers can be deployed on different computers. This brings 2 features. The first one is highly elastic. If a module has a lot of requests, only need to start more instances of this module instead of the whole GIS server. Another one is fault isolation. The modules are independent. Even if a module is crashed, others will not be affected. In SuperMap GIS 2020, we divided the GIS, the C++ kernel, into 4 packages. We provide 20 Java components and 33 web services. What are the benefits of doing this? It will reduce computing resources consumption. From SuperMap GIS 2017 to SuperMap GIS 2020, the average package size is reduced by 58%. The memory usage is reduced by 53%. And the startup time is reduced by 72%. In other words, the startup speed is 2.5 times faster. This is a geological big data project using cloud native technology. The system manages more than 400 TB geospatial data with more than 400 service instances running on the server, improving the stability and the performance of the system greatly. How to manage hundreds of services running on the server? This requires the use of SuperMap iManager and the Kubernetes to achieve automated deployment operation and management of back-end services, realizing loading balancing, service self-healing, and high elastic scaling. There are three values of cloud native: high availability, high concurrency, and high elasticity. High availability means that when our module crashed, the entire system will not stop working. The third is distributed geospatial analysis and processing technology. Distributed spatial analysis and processing technology is to decompose a single complicated task into several subtasks, allow multiple computers to work separately at the same time, and then merge the results. In this way, we can greatly improve the processing performance. Distributed geospatial analysis and processing include following parts. Based on Spark distributed computing framework, we provide geospatial big data analysis, GeoAI algorithm, reconstruction of classic geospatial data analysis algorithm, and distributed geoprocessing. Based on distributed computing technology, we have developed a large number of geospatial big data analysis functions, including streaming calculation, data summary, trajectory analysis, pattern analysis, and data filter. SuperMap GeoAI algorithms enable the distributed computing to improve the performance greatly. Distributed computing could not only help solving problems from geospatial big data and GeoAI, but also improving performance of classic geospatial data analysis. These are analysis algorithms for vector data based on distributed computing. These are some analysis algorithms for raster data. This year, we have implemented distributed processing for 3D data, including the inputting, processing, and service publishing of multi-source data. This improves the performance of the 3D system. This is the Geoprocessing toolkit, which supports web interaction and distributed computing. We can build the process through dragging and dropping and let the computer execute process automatically. This toolkit supports distributed algorithm. What's the value of distributed geospatial data analysis and processing technology? The answer is high performance. We conducted a test regarding vector data summary and analysis. It took 14 hours to complicate the computing by using the traditional algorithm. Well, the distributed algorithm only need 22 minutes, a rise in performance by 40 times. The fourth is distributed geospatial data engine technology. We developed the distributed geospatial data engine technology based on the distributed data storage technology to break the storage capacity limit of geospatial data and improve geospatial data storage management performance. For the traditional relational database, when the number of records reach the level of 100 million, the performance declines sharply. The distributed data engine technology could solve this problem. Distributed geospatial data engine technology could adopt to manage many types of data, including geospatial big data, classic 2D geospatial data, and 3D geospatial data. SuperMap distributed data engines include three types. we have 2 engines for file system, 8 engines for SQL database, 3 engines for NoSQL database. This is the massive land use data managed by SuperMap GIS based on the distributed NoSQL database HBase. It can realize high performance query and visualization. This demonstration system is based on SuperMap distributed GIS and Alibaba distributed database PolarDB. It achieved high performance managing and visualization of over 2 million records of aircraft location. This year, we released the distributed storage technology of 3D catch tile data. And based on it, we can input multi-source 3D data into MongoDB in order to improve performance of 3D rendering. We can use distributed 3D data management technology to empower game engines. GIS has very strong analysis function, and the game engine has better rendering effect. We can combine those 2 technologies. On the one hand, using 3D GIS to empower the game engine to make it have the ability of large-scale 3D data management and powerful GIS analysis function. On the other hand, using game engine to empower GIS can give the better rendering effect to 3D GIS. SuperMap released SDKs for 2 game engines. First of them is plugin for Unreal Engine. This is a simple demonstration. The large-scale 3D data is provided by SuperMap GIS, while the rendering effect is provided by Unreal Engine. We also provided plugin for another game engine, Unit. This is a game engine theme of Unit. All the terrain and building data are oblique photogrammetry 3D data, which is managed by SuperMap. There are 2 values of distributed geospatial data engine. One is large storage capacity. Another is high performance. This is transportation information system of Chongqing city in China. There are 3 billion records of new data every month. It's very hard to manage by traditional spatial database engine, but distributed geospatial data engine can solve this problem. In addition to this, what else can distributed GIS technology do? It can solve the problem of data credibility, protect data from malicious modification. Therefore, we have developed a new technology, Geo-Blockchain technology. We all know that blockchain, actually, it is a spatial distributed database technology. It has 3 features. The first is high safety. The blockchain data is repeatedly stored on different distributed nodes. If a service node is destroyed, the data will not lost. The second is that the data can be traced through the whole process. The third is high credibility. It can protect data from malicious modification. How can blockchain avoid data tampering? Blockchain is to divide the data into several blocks, then link them together. So we call it blockchain. There is a part of blockchain on the page. Let's see how it stores data. In each block, there is a hash code stored at the header. Hash code is a fixed length character string generated by our special algorithm from block data. If the slight change has been brought to the block, the hash code will be quite different. The modification will be recognized by system easily. The hash code is stored in this location. For example, the head of block 7 stores hash 6, which is the hash code of the previous block. The hash code corresponding to the block 7 is stored in the head of the block 8, and so on. If someone tries to modify the data of block 7, its corresponding hash code will be changed. Therefore, if you want to avoid being discovered by system, you must modify the hash code on the header of block 8. Next, the block 8 is changed, and the hash code on the head of the block 9 needs to be modified, and so on. Thus, it is necessary to modify all other blocks after block 7, which increases the difficulty of malicious modification. Besides, each chain is stored repeatedly on distributed nodes, which means that all copies of the chain need to be modified, which further increases the difficulty of malicious modification. What can we do by combining blockchain and GIS? We developed geospatial blockchain technology. It is a distributed geospatial data engine with high reliability. To develop a spatial blockchain, we need to choose a technical framework at first. We choose Hyperledger Fabric under commercial chain. This is a problem which needs to pay attention when we're using the Geo-Blockchain, because it has to solve the problem of temporal protection. Its performance is relatively low, and the space consumption is large, so it cannot store all data like a traditional spatial database engine. We could just put the key data to be protected in the blockchain for management. If the amount of the key data is to be managed is very large, how could we figure it out? We provide two ways. One is directly on-chain. When the amount of data is small, we directly upload the spatial data onto the chain. When the amount of the data is large, we store the data to external and then store the hash code, which is returns onto the chain. This is the technical structure diagram of the Geo-Blockchain. We have implemented the geospatial smart contract in the framework of the blockchain. On this base, we developed SuperMap I objects for blockchain. The core module is SuperMap SDX Plus for Fabric. SDX means Spatial Database Extension, the data engine of the Geo-Blockchain, and then the desktop software and the web server. The web server contains data history module that can trace the process of data change. SuperMap iManager can manage distributed services. Geospatial smart contract is a spatial chain code. It has three functions. The first one is to solve the problem of security. Through the digital contract, you can ensure that your operations are effective and legal. In addition, it is responsible for data organization and spatial indexing. We have 4 products related to the Geo-Blockchain. This is one of the products, the desktop software, SuperMap iDesktop X. In it, you can easily create and manage a blockchain dataset. This is an example of food traceability. Their key location data can be managed on the blockchain to avoid tampering. In the cadastral management system, it is easy to implement the trace function of parcel changing based on Geo-Blockchain. Besides, the key data like a parcel boundary line and boundary point can be managed by Geo-Blockchain to avoid malicious modification. There are many application scenarios of blockchain, such as space planning and land using control, real estate restoration and transaction, and natural resource management. Other domains include the food traceability, logistic location management of important items. Of course, the combination of blockchain and GIS has just begun. We just opened a small window. There are more applications we are looking forward to exploring with you. Now, let's have a review of the distributed GIS technology architecture. The first is the distributed geospatial data engine technology, including the file system, the SQL database, and the NoSQL database. The second is Geo-Blockchain technology, released this September. The third is distributed geospatial analysis and processing technologies, including geospatial big data analysis and processing, GeoAI, classic geospatial data analysis and processing, and distributed geoprocessing. The fourth is cloud-native GIS technologies. And the last one is edge GIS technologies. The values of distributed GIS can be summarized as high availability, high concurrency, high elasticity, high performance, large capacity, and high reliability. In a word, the current 5 technology system of SuperMap GIS is BitDC, which is developed from BitCC. B is Big Data GIS. I is Artificial Intelligence GIS. T is 3D GIS. C is Cloud Native GIS. The last C is Cross-Platform GIS. As we talked before, the Cloud Native GIS is part of Distributed GIS, so we change it to Distributed GIS. That's BitDC. In SuperMap company, we have more than 2,500 software engineers. I was one of them 15 years ago. So our vision is to create cutting-edge technologies, light up every corner of the planet with geointelligence. That's all for my presentation today. Thank you all for your patience.